Now this is the second part of the video on the lens, which will base on image formation on the lens. And before we go on into that, we need to first of all understand the principle guiding the formation of image using lens, as we had it under a curved mirror. So we all know the same thing. The first one is any ray parallel and close to this principal axis refract through principal focus. Then the second one is any ray through principal focus refract parallel and close to principal axis. And the third one is any ray of light through center of mirror, that is optical center, passes without deviation. Now, so let me just give you the summary of how to know where the image will form. If at all you have not drawn it, without even drawing it, you can still know what, where your image is likely to form. Like, look at this table. So we have object distance or object position, then image position. So if you place object, let's start from beyond 2F here, as we had it under curved mirror. Let's start from beyond 2F. Don't forget our 2F is standing for C in case of curved mirror. So if you place object beyond 2F, where will you find your image? Your image will come and form here between F and 2F. Between F. But if you place your object at 2F, don't forget our 2F is like C in the case of curved mirror. If you place your object at 2F, the image also will form at 2F. F. But if you place your object between 2F and F, so law of the plasticity of what? Like your curve. Then in that case, image will now come back to what? Go back to what? Beyond 2F. So between 2F and F to F. Beyond 2F. Then if you place your object at F, just like you have it in the case of curved mirror, if you place your object at F, your image will form at infinity. Then if you place object between F and C, that is F and center of optical center, your image will form other side. One image will not come back to this side instead of this side. Then in that case, we are going to have virtual image. So objects between F and C, virtual image. Now let's go on into practice and see how to draw the word ray diagram using lens. Now let's place object at object beyond 2F. Look at it. This is 2F. Let's have our object here. Just make sure you follow the principle. The principle says a ray from the head of object parallel and close to this principal axis will refract through what? Principal focus. I have my ray like this. Can you see? Then it will now follow what? Principal focus. Very simple. Don't forget to push your arrow. Then you can use any of the other two principles guiding formation of ray. So I can decide to use a ray through center of curvature. Go without what? Without deviation. So I then just decide to use what? A ray through principal focus. A ray through here. A ray through principal focus. Then it will now refract parallel and close to principal axis. Can you see? This is refracted. Then where the image will fall is where the two refracted rays meet. This is a refracted ray, this is another one. So we have this. So just make sure you make your measurement correctly, because the distance from here to here must be equal to distance from here to here. You actually get your image. And if you look at image form, you see that it's not as big as this. It means you may be asked to state the characteristic of image form. So one of the characteristics is what the image is what? Number one, is inverted. inverted. Inverted means it's what? Turned upside down. Look at the top. Look at the top here. Then number 2, it is real. So this one, that's what I told you in our previous video, that for the lens, we are expecting the image to form other side. But if the image now form the same side with object, it is what? Factual. It is factual. But if the image form the other side, it is what? Real. So this our image is what? Real. Then it is what? It is smaller compared with the object. So in that case, we say it is what? Diminished. Then another one that you can still state is it forms between F and 2F. It forms between F and 2F. Now let's try another one. Let's place object at 2F. Object at 2F. So once you know, you can see if object is at 2F, the image also will appear at 2F. Follow the same principle. We have this. Then where is it going? It's going to what? It's going to focus. Going to focus. Then don't forget your arrow. Then the next one, you can use a ray through optical center like this. So can you see it? So the two rays meet at 2F again. So therefore, our image, when we have the same size as object, since they are having the same distance. So the characteristic of image for number 1, it is what? It is inverted as well. Inverted. And number 2, it is real. Number 3, it's what? It's form unit magnification. Because the distance of object and distance of object and image, they are equal. So magnification will be what? 1. Don't forget, magnification is equal to image distance over object distance, or image height over object height. So it is what? Magnification is equal to 1. Magnification is equal to 1. It has unit magnification. Then number 4, it forms at 2F. At 2F. And what of if we now place our object at what? At F. If object is placed at F, so we have our object here. Object at F. Let's say a ray parallel and close to principal axis like this. So the ray is going to focus. Then we have this. Then we cannot apply a ray through a ray through principal focus again, because the object is already at principal focus. Then we must apply the third principle, that says a ray through center of mirror, optical center. We pass without division. So in that case we have this. That's all. So we have this one. Then if you look at the two rays, they are parallel to each other. They are parallel. So in that case, they can never meet, such that image will form at infinity. So please try other position. Place your object between 2F and F, then between F and C, and try and see if you are going to get the correct. If otherwise, please you can contact me through the word, the contact number on the screen, or so that you can join us every weekend. You see everything, you practice it yourself. Now, for the second part, that is the use of diverging lens. And like I told you in our previous video, that is the beginning of lens, is that we are going to base it on converging lens, that is by convex and by concave. Now we have seen how image form by convex, but remain what? By concave. You can see this is by concave, this is diagram of by concave, this is a concave, this is a concave. That's why we call it what? By concave. You see the difference? The major difference is that for this one, wherever you place your object, the image remains the same. The same thing applicable to that of concave mirror and convex mirror. Concave mirror form different image, depend on the position of object. But the convex mirror form the same thing. The image of convex mirror is always what? Diminished, virtual, and erect. That's why we use it as what? Side mirror of a car. Now let's try to place object any point in front of this diverging lens and see how it form image. Now let's say the object is here. Let's place object any point. So let's say we have our object here. So the first thing is we have a ray like we did in case of converging lens. So what will now happen? Instead of converging it to the focus here, so this one will diverge it away from the focus. It will diverge it like that's all. So the ray will now look as if it's coming from this focus. Now we have it here. We have to use dotted line because it is virtual. It's the back of the mirror. Then the next one is a ray through optical center. A ray through optical center, and you know the nature, it will pass without what? Deviation. So we have it like this. So and don't forget, this ray through this center or through optical center comprises of two rays. It's going like this. The incident is there. Refracted is also there, like this. So and this one is the refraction. And where the two refracted rays meet is where you're going to have your image. Automatically, our image is here. Can you see? Very small. But it's what? It is upright. So in that case, if you are asked to state the characteristic of image form, it's what? One, it is upright, that is erect. Image is erect. Number two, it's smaller, diminished. Then it's what? Instead of forming here, it forms at the other side. I said it. In case of curved mirror, we are expecting image to form in the same side as object. We call it what? Real image. But in case of lens, we are expecting object to form, image to form on the other side of the object. Otherwise, we call it what? Virtual image. So this one form in the same side as what? Object. We call it virtual. It is what? Virtual. So these are the three major characteristics of image form by what? Divergent lens. Wherever you place it, if you change the position of object, the image will still form this nature. It will still have this characteristic. It must be what? Virtual. It must be diminished. It must be erect. So you can try any other position. Then if you have any problem, if there's any problem, please contact me through my WhatsApp number. Don't forget, I said we normally have class on weekend basis, every weekend for science students only.